In 1930, a 50-year-old meteorologist basically froze to death out on the Greenland ice sheet.
Yeah, just a brutal way to go.
Right. And his body was actually buried under the snow with his skis just planted upright to mark his grave.
Which is, a very haunting image.
It really is. And the crazy thing is, at the time he died, the world's top geologists considered him a complete laughingstock. I mean, they openly mocked him in lecture halls.
Oh, absolutely. They tore him apart.
But today, literally every single middle schooler on Earth is taught his theory as absolute fact. So how did a guy who, studied clouds and weather balloons end up fundamentally rewriting the history of the ground beneath our feet?
Well, glad to be here to talk about it because it is honestly one of the most remarkable arcs in the history of science.
Definitely. And for you listening today, we are doing a deep dive into a collection of historical and biographical excerpts from Wikipedia about Alfred Wegener.
Yeah. And our mission today is to really look at how this total outsider changed the scientific field forever.
Exactly. We're getting into the extreme, deadly lengths he went to for his data and why the establishment just relentlessly rejected him for decades.
Because Wegener's story is the ultimate example of why we absolutely must question assumptions in science.
Okay, let's unpack this. Because to understand how he changed the ground, you actually kind of have to look up first. He didn't start out looking at rocks at all, right?
And not even close. He
Yeah.
actually started out looking at the atmosphere and the stars.
Which is wild. I mean, he got his PhD in astronomy, I think around 1905. What was he actually studying back then?
So his dissertation was focused on something called the Alfvén tables.
The Alfvén tables. What are those?
They were essentially these massive, incredibly dense astronomical charts that were created way back in the 13th century. They tracked planetary movements.
Oh, wow.
Yeah. And Wegener's job was applying contemporary computational methods to update this ancient planetary data.
Sounds like tedious work.
He was. And almost immediately after getting his doctorate, he just completely abandoned astronomy.
Just walked away.
Yep. He pivoted straight into meteorology and climatology.
Why the sudden shift? Did he just get bored of the math?
Well, he was really drawn to the dynamics of the atmosphere. He actually became an assistant at an aeronautical observatory, working alongside his brother, Kurt.
Oh, right, the balloon stuff.
Exactly. They weren't just sitting at a desk running numbers. They were actively pioneering the use of weather balloons to track air masses.
That sounds dangerous for 1906.
Extremely dangerous. They were pushing the absolute limits of human endurance. In fact, in 1906, Alfred and Kurt set a world record for a continuous balloon flight.
Really? How long were they up there?
They stayed airborne for 52.5 hours.
Wait, what? They just floated up there in a little wicker basket for over 2
Over 2 days, yeah.
How do you even, sleep or navigate or just survive the freezing cold up there?
You barely do, honestly. But they were up there to carry out meteorological investigations and to test celestial navigation methods in the elements.
That is intense.
It takes a tremendous amount of physical toughness, sure, but it also cultivates a very specific kind of mind.
What do you mean?
Well, think about it. You have to be comfortable suspended high above the Earth, just observing these massive shifting weather systems moving across the whole planet.
Ah, I see. So it's about scale. It kind of makes me think of, a modern software engineer just wandering into a biology lab and solving a massive genetic puzzle.
That's a great way to look at it.
Is it possible his lack of formal geology training was actually his biggest advantage?
It was really a double-edged sword. On one hand, his outsider status allowed him to synthesize diverse information, like meteorology, physics, and astronomy, to see the big picture.
Right, he wasn't bogged down by the geological dogma.
Exactly. But on the other hand, it made him a massive target for the geological establishment. They saw him as an intruder.
But it makes complete sense when you think about it. I mean, geologists at the time were looking at rocks like they were static photographs, right?
Yes, very rigid, unchanging.
But a meteorologist looks at the atmosphere like a movie. You've got fluid shifting, hot air rising, cold air sinking. It's all in constant motion.
Right.
So Wegener just looked at the Earth's solid crust and realized he was basically watching a very, very slow movie of fluid dynamics.
That is precisely it. He wasn't trained to look at an isolated rock formation in a single valley. He was trained to observe entire planetary systems in motion.
Which naturally leads to him looking at a map of the world and noticing that South America and Africa look like they fit together perfectly.
The famous jigsaw puzzle observation.
Right. But, wait, didn't people looking at maps already notice South America and Africa looked like puzzle pieces? Why was Wegener's idea so revolutionary?
What's fascinating here is that the geologist would have had a great point against him if Wegener was actually just looking at the beach. But he wasn't.
Where was he looking?
He realized that looking at the current shorelines was entirely the wrong approach. From at least 1910, he imagined the continents fitting together not at the current water's edge, but actually 200 meters below the surface.
Oh, down at the level of the continental shelves.
Exactly.
So he's matching up the actual foundational blocks of the continents, completely ignoring where the water just happens to be splashing today.
And when you match them at the continental shelves, the fit is incredibly precise.
That makes a lot of sense.
But he knew shapes alone wouldn't convince anyone. So between his first presentation in 1912 and the publication of his major book in 1915...
That's the origin of continents and oceans, right?
Yes. Between those years, he gathered an overwhelming amount of cross-disciplinary evidence.
Like what kind of evidence?
He analyzed matching rock strata, parallel geological structures, and even identical fossil plants on both sides of the Atlantic Ocean.
That's a lot of receipts.
It was. And that's when he coined the term continent.
Which is what we now know as Pangaea.
Exactly.
But wait, if he is bringing identical fossils from completely different sides of the ocean, how were the established geologists explaining that?
Well,
I mean, they had to have some theory for how a specific type of ancient fern ended up in both South America and Africa, right?
they did. The prevailing dogma of the time was a concept called sunken land bridges.
Sunken land bridges.
Yeah. The establishment genuinely believed that massive continent-sized bridges of land once connected Europe to America, or Africa to South America.
And the animals just walked across.
The idea was that animals and plants just migrated across these bridges, and then at some point, these massive land bridges just sank into the ocean depths.
Entire continents just sinking straight down to the bottom of the sea, like Atlantis.
That was the accepted science. But Wegener had read a paper in 1911 that pointed out a massive flaw in that sunken land bridge theory.
What was the flaw?
It contradicted a geological principle called isostasy.
Okay, what is isostasy?
It's the principle that the lighter, less dense continental crust essentially floats on the heavier, denser material of the Earth's mantle below it.
Okay, so kind of like an iceberg.
Think of an iceberg floating in the ocean, or even just a block of wood floating in a tub of water. You could push that wood under the water, but the moment you let go, it pops right back up.
Because it's less dense than the water.
Right. So Wegener argued you can't just have a massive land bridge sink into denser material and stay there. It completely violates the laws of physics.
Oh, wow. So he steps into their arena armed with basic physics, proves their land bridge theory is literally impossible, and presents a mountain of cross-disciplinary evidence showing the continents themselves moved.
He did.
And instead of thanking him, the geological world absolutely tears him apart. Why were they so vicious about it?
Because Wegener lacked the how.
The how.
He had an overwhelming amount of data for the
Correct.
the matching rocks and fossils,
Mm-hmm.
but he could not prove the mechanism of how giant land masses actually plowed through the ocean floor.
Right, moving a continent is a big ask.
And because he was desperate to provide a mechanism, he made some guesses. And those guesses were highly flawed.
What did he guess?
Well, he suggested the movement might be caused by the centrifugal force of the Earth's rotation.
So, like a spinning ride at an amusement park?
Sort of. The idea was that as the Earth spins, it acts like a giant centrifuge, slowly pushing the heavy continents away from the poles and toward the equator.
Okay.
He called it poleflucht, or flight from the poles.
Yeah.
He also suggested astronomical precession, which is the slow wobble of the Earth's axis over thousands of years, might be tugging the land masses.
And the math on those forces just didn't add up.
Not even close. The physicists of the time quickly calculated that centrifugal force and axial wobble were millions of times too weak to move a continent.
Oh, man.
Furthermore, Wegener got the speed of the movement wrong. He calculated the continents were drifting at about 250 centimeters per year.
And what's the actual speed?
Today, with modern instruments, we know it's about 2.5 centimeters per year.
Wow. Okay, that is a massive mathematical error.
It was, and it gave his critics a massive opening. They rightly pointed out that the oceanic crust is incredibly firm rock.
Right.
So for continents to move at 250 centimeters a year, they would have to violently plow through that solid ocean floor, which would just shatter the continents themselves.
Here's where it gets really interesting, because he made a mistake on the mechanism, and so they threw out the entire theory.
They threw the baby out with the bathwater.
And they got incredibly personal with their insults.
Oh, very personal.
Like, There's a quote from a German geologist, Max Semper, from around 1917, that is just dripping with academic condescension.
I know the exact quote you're talking about.
He essentially begs Wegener to leave geology to the professionals. He wrote this public request for Wegener to stop honoring geology with his presence, and suggested he go visit other specialist areas that had forgotten to write above their gates. "Oh, holy St. Florian, spare this house, set others on fire."
Yeah, that's just the academic equivalent of telling him to stay in his lane.
It's so petty.
It is. But this raises an important question about the human element of dogma.
Yeah.
The geologists of the time were not stupid people,
No, they were the top minds.
but they had built their entire careers, authored the textbooks, and established their professional reputations on a static Earth model.
Right, their whole identity was tied to it.
If you accept Wegener's theory, you are accepting that your life's work is obsolete. That creates a profound psychological barrier to new evidence.
And it wasn't just the European geologists defending their turf either. The North American scientific establishment was arguably even more hostile to him.
Oh, absolutely.
You had heavyweights like George Gaylord Simpson vehemently arguing for permanentism.
Yes, permanentism was this deeply entrenched idea that the basic layout of the oceans and the continents has been fixed forever.
Never moving.
Right. They believe that land masses never moved laterally. At most, the Earth's crust just moved up and down slightly, causing these periodic shallow floodings over the continents.
You also had prominent geologists like Charles Schuchert completely dismissing the jigsaw puzzle fit. He just argued that continuous erosion and changing sea levels would have ruined any puzzle piece fit long ago.
Which entirely ignores Wegener's data about the continental shelves.
Exactly. And there's this heartbreaking detail in the sources where Wegener is actually sitting in the audience while Schuchert delivers a lecture tearing his life's work to shreds.
And Wegener just sits there.
Yeah, he doesn't say a single word to defend himself.
Well, part of that may have been a language barrier, since Wegener's English wasn't perfect, but it also highlights a massive failure in scientific communication at the time.
How so?
In 1925, an American edition of Wegener's book was published, and it was a notoriously terrible translation.
Oh, really?
Yeah, it stripped out a lot of the nuance and was described as being written in an overly dogmatic style.
That's the worst possible thing for his reputation.
So the North American scientists read this poor translation and basically just saw an arrogant outsider making wild, unfounded claims.
Though the sources do point out that the rejection wasn't entirely universal. I mean, European researchers in the 1920s actually started to embrace the main tenets of his theory, right? They were largely debating the specific details rather than just outright dismissing it.
True, he did have early, vocal supporters like Alexander Du Toit in South Africa and Arthur Holmes in England.
Okay.
But the broader institutional acceptance, especially in North America, remained an absolute brick wall.
So because the establishment demanded proof of modern climatic and atmospheric mechanisms before they would even consider buying his theory of the deep past, Wegener realized he had to go back out into the field to get the data.
He had to prove it.
And he chose the most unforgiving, dangerous place on Earth to do it, Greenland.
Right. Between 1906 and his death in 1930, he participated in 4 separate grueling expeditions to the Greenland ice sheet.
4 times.
Yes. He fundamentally believed that to understand the mechanics of the Earth's past, you had to measure the extremes of its present climate.
And the details of these expeditions are just staggering. I mean, on his first trip in 1906, they are trying to map the last unknown portion of the northeastern coast, right?
Right.
So Wegener builds the first meteorological station in Greenland, launching tethered balloons into the freezing Arctic winds. But then the expedition leader and 2 colleagues die on a sled dog trip.
It was devastating.
Yeah.
But Wegener survived, and he actually called the trip a decisive turning point in his life.
He witnessed the sheer power of the Earth's climate firsthand, and it didn't deter him at all. It just focused him.
Exactly. So he organizes a second expedition in 1912 with Johann Peter Koch.
And this one is pure survival horror.
It really is. Almost immediately after arriving, a calving glacier nearly wipes them out.
And doesn't his partner get hurt?
Yeah, Koch falls into a hidden crevasse and breaks his leg. So they are forced to become the first people to ever overwinter on the inland ice of northeast Greenland.
Just trapped out there.
Trapped in a tiny hut. And while they're there, they actually use a hand auger to manually drill a 25-meter ice core.
That is insane dedication.
But then, the following summer, they attempt to cross the inland ice, and they completely run out of food.
Oh, no.
They're forced to kill and eat their own dogs and their pack ponies.
That's awful.
And they're only saved from starvation at the very last second by a visiting clergyman who just happened to be at a remote fjord.
It blows my mind. I mean, this isn't a lab experiment. This is like trying to do climate science on the surface of Mars with 1910s technology.
It's a profound level of dedication. He was doing foundational work in polar air circulation before the jet stream was even a recognized concept.
Wow.
In fact, he and his father-in-law, Vladimir Kuffin, practically co-founded the field of paleoclimatology. Wegener understood that ancient climates were directly tied to the movement of the continents.
He was just surviving by the skin of his teeth, literally eating his pack animals just to get the data the establishment demanded.
Which brings us to the 1930 expedition. This was meant to be his crowning achievement. The German government backed him with $120,000, which is equivalent to about $1.5 million today.
That's a huge budget for back then.
It was. He had 14 participants and 2 innovative propeller-driven snowmobiles. The goal was to establish 3 permanent stations across the ice sheet to measure its thickness and make continuous year-round weather observations.
But the margins for error in the Arctic just don't exist.
No, they don't.
A late thaw sets the entire expedition 6 weeks behind schedule. And the men who are stationed at the central camp, which is known as IceMid or mid-ice, they send this desperate message.
They were in serious trouble.
Right. They basically say they don't have enough fuel or food to survive the winter, and they plan to abandon the camp and march back.
And because of the massive government funding, Wegener feels an immense personal responsibility. The entire scientific success of the mission depends on keeping IceMid operational.
So what does he do?
In late September, with the route markers completely buried under fresh snow, Wegener sets out with a meteorologist named Fritz Loh and 13 Greenlanders to run supplies up via dog sled.
But the conditions they marched into were practically apocalyptic. The temperature plummeted to minus 60 degrees Celsius.
That's minus 76 degrees Fahrenheit.
That is unfathomable cold.
At those temperatures, machinery fails, and the human body simply begins to die.
Right.
Loh's toes became so severely frostbitten that they actually had to be amputated right there on the ice.
Oh, my God.
They used a penknife.
With no anesthesia.
There was no anesthesia. And at that point, 12 of the Greenlanders realized it was a suicide mission and turned back.
Smart move.
Only Wegener, the injured Loh, and a 27-year-old native Greenlander named Rasmus Wilhelmsen finally reached IceMid in mid-October.
And the most tragic part of this whole thing is that the desperation was entirely based on a math error.
It's just sickening.
Another expedition member at the central camp had miscalculated their remaining supplies. He assumed there was only enough food for the 3 men already there.
Right.
But in reality, there were enough rations that Wegener, Loh, and Wilhelmsen could have safely stayed and overwintered.
But they didn't know that.
No. Believing they would cause the entire camp to starve if they stayed, Wegener and Wilhelmsen took 2 dog sleds and immediately headed back out into the minus 60-degree storm toward the west camp.
And they took no food for the dogs. They had to kill the dogs one by one to feed the surviving ones until they were reduced to just a single sled.
That is bleak.
Wilhelmsen rode the sled. But Wegener, who was a 50-year-old heavy smoker, had to ski alongside it through the snow.
And they never made it back.
No, they didn't.
6 months later, in May of 1931, a search party finds the upright skis. They dig down and find Wegener's body.
They determined he likely died of heart failure from the sheer impossible overexertion.
And then they built that pyramid-shaped mausoleum out of ice and snow and just left him there to rest.
Yeah. And Wilhelmsen, who presumably buried him and planted the skis, was never seen again.
So Wegener dies at 50. His life's work is still mocked by the dominant American geological establishment. He never gets to see the world catch up to his genius. So what does this all mean?
Well, the world did catch up, eventually. And his vindication is one of the most satisfying delayed arcs in the history of science.
When did things finally change?
The turning point really arrived in the early 1950s with the emergence of a new field called paleomagnetism.
Okay, paleomagnetism. How does that work?
It's fascinating. When lava erupts and cools into solid rock, it contains tiny crystals of iron-rich minerals like magnetite.
Okay.
While the rock is still hot and fluid, those tiny iron crystals act like microscopic compass needles. They physically align themselves with the Earth's magnetic North Pole.
Because they're magnetic.
Exactly. And when the rock cools and hardens, those compass needles freeze in place, forever pointing north.
So they are essentially recording the exact magnetic direction of the Earth at the specific moment that rock formed.
Yes, exactly. So the 1950s, Geologists started studying ancient rocks in places like India and Africa.
And what did they find?
They found that the microscopic compasses in these ancient rocks weren't pointing toward the North Pole anymore. They were pointing in completely bizarre directions.
Oh, wow.
The only logical explanation was that the magnetic pole hadn't moved. The rock itself had moved thousands of miles from where it originally cooled.
That's incredible. So the rocks literally contain the compasses pointing directly back to Wegener's theory.
The evidence was literally baked into the stone.
And then in the 1960s, you get researchers like Marie Tharp and Bruce Heezen starting to map the ocean floor using sonar, right?
Right, and they discovered the massive mid-ocean ridges.
Which changes everything again.
It was the final puzzle piece. Wegener had actually speculated about this decades earlier. They discovered seafloor spreading.
What's that?
Magma rises from deep within the earth at these mid-ocean ridges, cools into new rock, and physically pushes the existing oceanic crust apart.
Ugh. So that was the how. That was the mechanism powerful enough to move continents.
Exactly.
But wait, if the Earth is constantly making new crust at the bottom of the ocean, wouldn't the planet be getting bigger?
That was the next major discovery. They identified what are known as Wadati-Benioff zones.
Wadati-Benioff zone.
Yeah. If new crust is created at the ridges, old crust has to be destroyed somewhere else. Wadati-Benioff zones are these deep, angled fault lines at the edges of continents where the heavy, dense ocean plate is violently shoved underneath the lighter continental plate.
Oh, and it melts back into the Earth's mantle.
Precisely. The Earth's crust was constantly being recycled.
So continental drift finally evolves into the modern theory of plate tectonics.
Yes. And if we connect this to the bigger picture, the ultimate cherry on top came in 1993.
What happened in 1993?
With the advent of the Global Positioning System, GPS, scientists were finally able to measure the drift directly.
Like from space.
Yeah. We could literally bounce signals off satellites and watch the ground move in real time.
And the speed of that movement.
About 2.5 centimeters a year.
Which is exactly what the modern models predicted and what Wegener missed by that couple of decimal places.
Exactly. Wegener's mathematical calculation of 250 centimeters was wrong, and his mechanism of centrifugal force was wrong.
But his fundamental vision, the idea that the solid ground beneath us is constantly in motion, was flawless.
He is now universally recognized as the founding father of one of the major scientific revolutions of the 20th century.
Which brings us back to you listening right now. Why does a German meteorologist from a century ago matter to your life today?
It's a great question.
Because Wegener's story is an absolute masterclass in trusting your own observations. It's about having the courage to look at the evidence in front of you, whether it's the shape of a coastline, a fossil in a rock, or a pattern in the weather, and believing what the data tells you.
Even when the loudest, most credentialed experts in the room are telling you that you are out of your depth.
Exactly. And even when defending that truth requires walking into the freezing dark.
He fundamentally understood that the Earth doesn't care about our rigid academic boundaries. The atmosphere, the deep oceans, the ice caps, and the solid crust beneath us, they are all part of one single, profoundly interconnected system.
And as a final, beautiful little footnote to all of this, while he was busy rewriting the entire history of the Earth, breaking world ballooning records, tracking tornadoes, and surviving the brutal Arctic, his mind never stopped observing the small mysteries of the world, too.
He was endlessly curious.
He really was. In 1918, he actually introduced a scientific theory on the growth of something called hair ice.
Hair ice.
Yeah, I highly urge you to go look up hair ice on your own. It is this incredibly strange, delicate, cotton candy-like ice phenomenon that grows on rotting wood.
That sounds fascinating.
It's just one more testament to this brilliant, relentless mind that tried to explain absolutely everything from the violent collision of supercontinents all the way down to the delicate frost on a fallen branch.